All right, my next one is number 7. I'm trying to do as many as I can today because before I send out your exam, no one asked about number 1 yet. We did number 2, we did number 3, we did number 4, 5, 6. 7, I just worked it out on Sunday night, but I didn't record anything because my son was running around like crazy, and so I really couldn't record anything. So I'm gonna go ahead and go over number 7 one more time, actually talking through it, and then I will come back and do number 10 too. And I'll just keep on checking my email to see if you guys need anything else. But let me go ahead and erase everything over here, okay? And I'll just start from scratch. Okay, bye-bye. Now I got the picture from just graphing on Desmos. And since I'm gonna ask you to kind of draw your own diagram on the exam, oh dear, that'll be fun. I'll ask you to, I can make, yeah, that's the biggest. I'll ask you to, just graphing a linear function. That's not gonna be too difficult. But labeling everything and seeing a picture will be very helpful. So let's start number 6 without a picture. Okay, so let me go ahead and just get rid of this picture. If I can, I don't think I can. But let me show you how I got this picture, okay? So relative to the center of a town, a power line runs a straight line from a point 10 miles north of the town. So what I did was, and if you can read the hint part that comes right here, it says, take a look, let the town be at the origin at 0, 0, and well, that part first. That's why I put center of the town at 0, 0 right here, okay? So put the center of the town at 0, 0, and look at this part that I just read. It says, a power line runs on a straight line from a point 10 miles north of the town. 10 miles north of the town. So north is going up, right? North is going up. So that's why from 0, 0, I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and put this point right here. This is the north end point of this town, or the power line. What else? And they also said 5 miles east of the town. So north, south, east, west. So from the origin, I go a 10 up for north end point, and I went 5 to the right for east end point. And then what you do is you connect these two dots, and that's going to be the power line, okay? And that power line has an equation of y equals 10 minus 2x. Take a look and see why, okay? You do know how to write an equation of a line given 2 points. This line has a slope of -2, right? It's going down 2 over 2 to the right, going down 2 over 1 to the right. So slope is -2. But what is the y-intercept? Y-intercept is at 10. So that's why, and I'll give this to you too. I'll give you on the exam what the equation of the line is so that you can just use it. But you know exactly where that y equals 10 minus 2x came from. So that is the equation of a power line. They're going to build something called a spur line. A spur line is to be built from this main line. So this is the main line that we just highlighted in yellow. This is the main line to the center of a town. So what we're going to do is from this center to somewhere on this, let me see if I can draw like a straight line. Take a look. So if the spur line goes straight up like that, the distance will be 10, right? Because there's a straight up distance. But a spur line can be, wow, this is super cool. James, you never bother me. James, this is good. Okay, hold on. Let me go ahead and close this tab. Like go down like that. You see how the spur line visually is getting shorter, right? It's getting shorter and shorter and shorter and shorter and shorter. So like I'm thinking somewhere around there it will be the shortest. But I mean, if you go down this way, the spur lines, the length will be how long? 5-ish, right? Exactly 5 right there. So I'm thinking that's why I kind of drew this like dotted line over there. But I do not know exactly what point without doing math, right? So somewhere on this spur line called xy that needs to satisfy this equation, right? And the goal is to, I'm kind of assuming that you kind of read the problem already. We're trying to minimize the length of this spur line. So the shorter it is, it will be the cheaper to build, don't you think, right? So what we want to do is minimize this distance, this black line that I just drew. Let me go ahead and highlight this with black highlighter. So what you want to do is you want to minimize this length. The shorter the spur line, the cheaper the cost it will be to build it. So somewhere on this point, and you know when I said somewhere on this point, somewhere on this line, that's the constraint here, right? It has to be on this line because you cannot you cannot build a spur line, let's say, out like that. Or you cannot have it like this. It has to be connected to the main line. So that's not good, that's not good, that's not good, that's not good. But if you connect it to the main line, then that's what we want. And to be on this main line, x and y needs to satisfy that equation. So somewhere on this line is what we're going to find. So let's go ahead and set up some work here, okay? So that's the diagram, and it will definitely help you, right? And some great hint over here. Let the town be at the origin. That's what we did. And minimize the distance between the origin and the line. So that's what we're going to do. We're going to minimize this gray highlighted line so that we can build the cheapest spur line as possible. So A, at what point along the power line should the spur line be built in order to minimize the cost of the spur? Now, this is going to take us about 3 pages. Not really, just because I write big. But, you know, B is going to be easy. As soon as we find out how long this is going to be, now take a look. They did say this. They said, different color. Cost to build a spur line is $45,000 per mile. So if we know, hey, this is going to be 2 miles or 4 miles, all we need to do is just multiply that number of miles by that cost. And that's how easy B is. But A is going to take us some time and some good work to find. So let's go ahead and start this. And I gave you a great hint over here. We said, minimize the distance between the origin and the line. Now remember, there is a distance formula. So I want you to write that down. Distance formula goes like this. D equals square root of x2 minus x1 squared plus y2 minus y1 squared. You guys learned this in a geometry class. We're going to use this to find the distance between the center of the town or somewhere on this power line, and we will actually minimize that distance. Now, here's a good news, though, that you're thinking, oh my goodness, there's so many unknown variables. That's not really true. Take a look. We do know one of the point. One of the point is the center of the town. Whose order pair is what? 0, 0. So this is what I can do. I can simplify this. One of the point is 0, 0. So I can say x2 minus 0 squared plus y2 minus 0 squared. Why? Because one of the point is 0, 0. And there's no reason for me to use these subscripts anymore. So how about I just simplify this into x squared plus y squared, right? So thank goodness we're just going to work with that equation. And not only that, We'll even make it better now. Okay, ready? So, do you understand how this distance formula turned into something as simple as that? Why? Because one of the point is 0, 0. That's gotta be that 1 point, center of the town. So the x1 and y, I just made them 0. And if you're wondering about what happened to the subscripts, I just got rid of them just because now we only are looking for 1 point on this main line. So I don't really need to call it x1, y1, x2, y2. So I just got rid of them. So this is the equation. But now you're still thinking there are too many unknown variables. I mean, I don't know what x is. I don't know what y is. But here's the thing, though. We know the constraint, right? Something's going to help us. We know one of the conditions that x and y must satisfy, this point must satisfy, is that it must be on the main line, right? If it's not on the main line, it's not going to be good. So remember the main line equation. The main line is y equals negative 2x plus 10. That is the constraint that we're going to use to rewrite this distance equation. So take a look. D equals square root of, leave that x squared alone. But what is y, guys? Y is negative 2x plus 10, right? So what we are doing is we're plugging in that constraint equation into this distance equation. Ta-da! Now take a look. What is the only unknown variable now? The only unknown variable is x. So let's do some work simplifying this distance formula. X squared plus, I'm going to FOIL this, but I'm going to write it out twice so that I can actually FOIL this correctly inside. D equals square root of x squared, and this is just algebra now. If I multiply out these two, I will get 4x squared, right? And then the middle terms will be negative 20x and another negative 20x, so I will get minus 40x. And then lastly, 10 times 10 will give me 100. So if I simplify that distance formula, I can combine like terms and get 5x squared minus 40x plus 100. Now, we need to use calculus now. Why? Because this is what I want to do. What do you want to do with this distance? You want to minimize this, right? And we learned how to find local or absolute minimum or maximum in our class. And that is to find the derivative and set it equal to 0. Or I shouldn't just say set it equal to 0. We should find the derivative and find the critical values by finding where this derivative is equal to 0 or where it is undefined, right? So let's do that. Let's find dx. Let's find the derivative of this distance equation with respect to x so that we can find some critical values. So let me go ahead and move my work down there. And why not? Let me just write this as a function format. d of x, the distance in terms of the x-coordinate. And look, the x-coordinate stands for what in our word problem? It's the distance to the east side, right? To the east. So how about I rewrite that square root notation as 5x squared minus 40x plus 100 raised to the what power? 1/2 power. Now I'm going to find the derivative of this. I think on the previous attempt, I just wrote it as dx, but that's the same thing as d prime of x, whatever notation you want to use. But let's find that derivative. 1/2 times, bring down that exponent, right? 5x squared minus 40x plus 100. What's the new exponent? You need to subtract 1 from 1/2. So that's going to be negative 1/2. And then remember, chain rule. We need to multiply this by the derivative of the inside part. And I know you can do that in your head. And I'm just going to go ahead and write down my plan. My plan is to multiply this by the derivative of the inside part. So let me just copy down this. And then the derivative of the inside part is 10x minus 40, right? I'm going to go ahead and put this in a nice looking form, answer. So what we are finding is d prime of x because we're trying to find the critical value. Now, you notice this term has a negative exponent, so I'm going to go ahead and just write this in the bottom of the fraction. So write down 10x minus 40 on top of the fraction, and write down 2 times, and you see that is raised to the negative 1/2 power, so I'm going to write it as square root of 5x squared minus 40x plus 100 in the denominator under square root. I can simplify this 2. I can divide these numbers by 2 and write my derivative as 5x minus 20 divided by square root of 5x squared minus 40x plus 100. Now, sometimes when you're in a long journey, you sometimes forget where you're going with this. But remember, we're trying to minimize this distance, and distance is minimized we're really trying to find what? Relative minimum, right? Relative minimum. And we got a relative minimum on the critical value. So what we're going to do is find critical values using this. Find critical values. Critical values happen when the function is equal to 0. So first find when d prime of x equals 0. But not only that, when this derivative function is undefined. And for polynomial functions, we only really found where it is equal to 0, because for like polynomial functions like quadratic, cubic, they're always defined everywhere. But this is a rational function, right? You see, it's a fraction. So if the bottom of the fraction is 0, then it's going to be undefined. So you got to consider both cases. Now, the function, the d prime of x, will be equal to 0 when the numerator is equal to 0. Right? When the top of the fraction is equal to 0, then the whole fraction is 0. So that is 5x minus 20 equals 0. If you solve that, you get x equals 4. So circle that. That is a potential answer. 4 miles to the east. That's what we got, right? But notice, 4 miles to the east, that means we're probably looking at that point right there, because it has to be on this power line. That's the potential answer. But I also may have some other potential answers when d prime of x is undefined. So this is when denominator is equal to 0. So what is the denominator? It's square root of 5x squared minus 40x plus 100 equals 0. Not only that, hold on. And if I square both sides, I will get 5x squared minus 40x plus 100 equals 0, right? But notice that x must be, or this discriminant must be greater than 0. So, well, what am I saying? Let's just go ahead and solve for this x, okay? Using the quadratic formula, or is that the only option? Why not? Because at this point, guys, like, you learn that things in real life, like in like real world situation, they're not really going to be solvable by factoring unless your math teacher like designed it that way. But I don't think this was designed to be solved by factoring. Who knows? But let me see. Let me see if I can try to factor out 5 out. And then I get x squared minus 8x plus 20, right? Equals 0. Is this solvable by factoring? Is there a number that multiplies to be 20? 10 times 2 is 20, but they need to have the same sign. Well, because I was thinking like something like plus 10, oh no, I'm sorry. Minus 10 and then like x plus 2 so that they add up to negative 8, but they're not going to add up to or multiply to be a positive 20. So it's not really going to factor. So just do the quadratic formula, and on your exam, make sure you show me every work. It doesn't matter how many pages you take. We're going to do quadratic formula. I think on my previous attempt, I used A is 5, B is 4, negative 40, and C is 100. That's okay if you want to do that, but if you factored out the 5, you're just working with smaller numbers, that's fine. So let's do the quadratic formula. X equals positive 8 plus or minus square root of negative 8 squared minus 4 times a times 20 divided by 2 times a. X equals 8 plus or minus. Now you'll notice it. Negative 8 squared is what? 64, right? And I do 4 times 1 times 20. 4 times 20 is 80, isn't it? And the denominator is 2. X equals 8 plus or minus. What is 64 minus 18? 64 minus 18 is negative 16, right? And now, because we're good with math, I can simplify that to be a plus or minus 4i divided by 2. But here's the problem, though. We're talking about what? Going imaginary direction to the east this time with that I. I mean, by that time when that 64 minus 80, the discriminant comes out to be negative, you know there's no real solution. So, I mean, if you want to list your imaginary solutions, you're talking about going 4 plus 2i to the east or 4 minus 2i miles to the east. I mean, this doesn't make sense. So because this is not real solution, this isn't going to be our answer to a real world problem, right? Because where X stands for how many miles we have to go to the east, right? So throw that out. Unfortunately, all that hard work that we did wasn't going to get us anywhere. But here's the good news, though. We know that when we go to X equals 4, when we go 4 miles to the east, something's going to happen. That's the critical value. So, I guess you can do two things here. You can, because remember in one of the sections, we talked about how to find absolute minimum. And one way was plugging in this critical value into the original function along with the other endpoints of this interval. And this interval goes from what? X. Now we're talking about X, right? X ranges from what number to what number? X may be 0 when you go build X may be 0 if we're talking about that point up there, or X may be 5. So the interval, the closed interval for X is going to be from 0 miles to 5 miles. So you may want to do that in a closed interval 0 to 5. You may want to find what's the distance at 0. What's the distance at that critical value that we just found? And that was 4. And what is the distance at 5? Because there were no other critical values in this interval 0 to 5. If you check these 3 and pick the smallest distance, that's how we're gonna find the absolute minimum in this closed interval. Another method that we also talked about is using the second derivative, right? If the second derivative comes out to be, oh gosh, I forgot. You gotta find the second derivative and plug in that 4 in there. If it comes out to be concave up, positive, then we're gonna say, hey, this is a concave. Jesus, I'm confusing myself. But, the method that I used is, and what I suggest you do, is if you take a look at it. I mean, I don't really want to take the second derivative of that mess. So, just to make our life easier, how about we just plug in, going with the first method, which is perfectly good, plug in the endpoints into the distance function and plug in that X equals 4, that one critical value that we found into the distance function, and figure out which one gives you the shortest distance, okay? Now, real quick, what's the distance function? Here it is. Distance function is this. I'm going to go ahead and do this and see if I can copy. Oh, I know, I learned how to copy. Okay, so down here, I'm going to go ahead and paste image. So this is the distance function that we're going to plug in to find the distance at each of the 3 of these endpoints. So first one, when I plug in 0, 5 times 0 squared minus 40 times 0 plus 100. Now what's that going to be? Square root of 100, and that equals 10 miles. Of course, right? I mean, think about it. If you do not go any miles to the east, then to be on the power line, you have to go up 10 miles north and plot your, or build your spur line over here. Like the spur line will look like this, right? So when the x is 0, y will be 10, or I'm sorry, the distance will be 10. You can also just count the vertical distance from 0 to 10. Now, what if the other endpoint, the endpoint, if you build a power line over there or spur line like that, 5 miles to the east, how long will that spur line be? 5 miles, right? Because you go 5 to the right and that's where you build it. So I already know the last one too, but let me go ahead and just show you work for it, right? So that will be 5 times 5 squared minus 40 times 5 plus 100. Now we're going to get square root of 25, but why not? We'll check it just for fun. If I do 5 times 5 squared, oh, that's having 5 quarters. I have $1.25 minus 5 times 40 is 200 plus 100. Now what's that going to be? If I add these two first, I will get 225. 225 minus 200 is 25, therefore 5 miles. So some unnecessary work, but just to show you our distance formula is good. Now, one answer gave me 10 miles, the other answer gave me 5 miles. So if somebody doesn't want to do any math, they should probably just build it 5 miles to the east. But we got a critical value that we're going to test out now, and that critical value is when x equals 4. And we don't know the y value yet, so we should check it out. If this number comes out to be the shortest, that's going to be our answer. 5 times 4 squared minus 40 times 4 plus 100. And that's going to be what? 16 times 5. What's 16 times 5? Is that 80? Okay. 80 minus 40 times 4 is 160 plus 100. And if I add 80 plus 100, that's 180. 180 minus 160 is 20. And square root of 20 is approximately what? 2 square root of 5. And I guess we can do this without a calculator. You know how you learn how to use marginals to just approximate square root of 5. That's approximate like 2 point something. But let me go ahead and just be very accurate. Type in 2 square root of 5 in my calculator. And then that comes out to be 4.47 miles to the east direction, right? 4.47. All right, I'm going to circle 3 numbers for you. First answer was 10 miles. Second number is 4.47. And the last answer is 5. Which one is the best? Which one is what we want? Remember, we want to minimize the distance of the spur line, this length of the spur line, because we wanted to build it the shortest, right? The shortest it is, the cheaper it is. So the answer is 4.47 miles. And I think I want you to kind of answer number 7. 4 miles east until, why in the world are they saying 4 miles east? Shouldn't it be 4? Could it be the rounding? No. Wait. I'm sorry, I messed up. So what I just got, the 4.47 miles is the length of this spur line. X is 4. So what does X stand for? X stands for the number of miles to the to east, right? The number of miles to east. Y stands for number of miles to north. I don't know if my grammar is okay. Number of miles to east. So number of miles to east will be 4 miles to east. 4 miles east to east. And y, now when you evaluate a function, we kind of tend to think, hey, we found the y value. But now remember, in order for you to find the y value, take a look at this picture for me. You go 4 to the right. Where is the point at? Point is right here. Looks like the order pair is going to be 4, 2. But then the question is, how do we get that 2 by using an equation? Now look, y is equal to -2 times the x value of 4 plus 10. Therefore, we get -8 plus 10. So what we got is we need to go up 2 miles north to have a point on this main power line. So that's why, I almost freaked out, guys, sorry. 4 miles to north. That is the best position to build the spur line. 4 miles east and 2 miles north is where we want to put it, because that's going to minimize that distance. So how are you going to explain this other number that we found? What does this 4.47 miles mean? And that means this green line. And you can use the Pythagorean Theorem to find this number. Notice that the horizontal distance is 4. This base is 4. It's a right triangle, and you go up 2. So if you find the distance from center to that point right there, that's going to be approximately 2 square root of 5, 4.47. So we talked about 3 different measures. X stands for how much to go to east, or Y stands for how much you should go up to north, and the D of X, that stands for the distance. Or we could, and once you figure out 4 miles east, 2 miles north, you can, I guess, use the distance formula to plug in or find it using Pythagorean theorem, because you will need to find how long the spur line is going to be in order to figure out the cost for them. So, all right, so we know the spur line has to be 4.47 miles long. So let's answer the very last question. What is the minimum cost? Now, we just found out, let me squeeze in the work right over here, okay? We just found out that it has to be 4.47 miles long, right? And it's going to cost this town $45,000 per mile, right? So go ahead and do 4.47. Oh, maybe I can just go ahead and do answer, whoopsies. This times $45,000. Hold on, guys, I forgot. Was it really $45,000? Yes, it was. $45,000. And if I hit multiply or hit enter, it's going to cost this town $201,246.12 to build this spur line. So what am I doing? I'm taking a picture of this so that I can go write this down and compare it to the answer that I got earlier. So this one, the answer should be, how much money is expensive? $201,246.12. And that sounds expensive, but that is the minimum cost, because that is the shortest distance, right? So let me double check if I type that up as part B's answer, 201,246. Let's go down. 201,246.12 cents, exactly the same. All right, so I think that's a beautiful problem. It's a final exam problem, so I'm like, why not? You can do it. So I'm gonna just create something similar though, right? I'm not gonna make it super different. So just make sure you understand every piece of it and let me know if any parts of it does not make sense, okay? All right, so I will be back with the very last one that I got an email about was number 10. So I'll do number 10 and that's gonna be it.